Her research focuses on the fundamental cognitive operations and neural processes involved in making decisions, and on how our decisions are affected by mind wandering on the one hand and meditation on the other. She makes use of a combination of computational modeling, neuroscience, and experimental psychology tools. She has developed a unique approach to studying meditation by using computational models of cognition. More recently, she has started to build models of the meditation and mind wandering to better understand why, how, and when we get distracted. In addition to this academic career, she has been a practicing Tibetan Buddhist since 1998, and she is also a semi-professional classic ballet dancer. She pursues projects where science, art, and contemplation meet. For example, in 2018, she started an interdisciplinary arts-science collaboration with Random Collision Performing Arts School to investigate the nature of human connectedness with interbrain synchrony and dance. She will be speaking to us today about Tibetan monks, dancers, and understanding the role of interbrain synchrony in human connection.
Hi everyone. So my talk is going to be a bit more speculative than the previous two, which were pretty data rich. This is just work that's still quite ongoing, but arguably neuroscience in the wild. So these are the pictures of showing the essence of some of my exciting projects. So here you see Tibetan monks in the laboratory in Sarajay Monastery in India. And here you can see two dancers in action. And actually in that particular tryout of the show, they thought it would be fun if I would be carrying around the cables, which you actually also saw in Lena's video, like carrying around cables, but then me on my point shoes. So that was kind of an entertaining thing. After that, I got deleted from the show, but I was back to just normal cable carrying, but you'll see. So before we get started, obviously it's not just me, it's a whole bunch of people. So for the monk study, these are some of the main people of the team, which you can see includes a lot of monks, some of whom have actually been here a few years ago. So that's really nice sort of to bring that back here. And this is some of my dancers team, and especially a PhD student, Lionel Newman, and postdoc Debarati Bandyopajai, if I pronounce her name correctly, and two dancers who are also critical members of the team, because maybe if I want to make one point, it would be that my vision of doing neuroscience in the wild is not just doing neuroscience in a condition outside the lab, but also trying to really consider the context in which you are working to be one in which you collaborate with these people. So collaborate with the monks rather than just using them as guinea pigs. So in addition to it being a learning opportunity for us, trying to figure out what the monks are doing, which I'll motivate in a little bit, it's also a learning opportunity for them on how science works by being active collaborators in the work. And similarly for the dancers, while we are investigating the role of social connection on brains through movements, they're investigating social connection through movement by means of movement research. So it's two goals being accomplished at once. And that's really important to the philosophy of these projects. So let's start on how did I get involved in science with Tibetan monks. I'm sometimes asking myself also that question because it's kind of a convoluted story. It started in 2014 when I was asked to come to India and teach Tibetan monks about my research on computational modeling, or in general research on the mechanisms of meditation. And as I was there teaching, not for Emory Tibet Science Initiative, but for Science for Monks, another kind of monk education project, I saw the monks debate together with my colleagues, and I was like, wow, that's a really interesting behavior. You'll see it in a second in some of the videos. This is contrary to what a lot of people believe that monks are doing, which they might think a lot of people think that monks sit in a cave and meditate. Actually, most of the time they practice a reasoning-based meditation, which is also very physically active as well. And I wanted to know what's going on there. What are they doing? What does it mean? What are the mechanisms underlying this practice, cognitively, emotionally, and in the brain? So we set up a collaboration together with Science for Monks with Sarah J. Monastery to jointly collect data. And the benefit for us is learning about this practice and about this, well, it's pretty critical practice because this is, for example, one of the main things that has made the Dalai Lama who he is. So he mostly doesn't sit still and meditates. He actually does a lot of this debate to sharpen his mind. And the benefit for the monks is learning about science, because learning science from textbooks, as you all know, is very different from how it works in the wild, how messy it is, how, well, what a struggle it often is. So taking them along on the ride has been, I think, very interesting for all of us. So this is what a Tibetan monastery looks like, in particular Sarah J. So at any morning and evening, they have these debates where you see literally hundreds or even thousands of monks sitting there debating about what they've been studying, what they've been memorizing earlier that day or last night. So it's actually a fascinating sight. It's a cacophony. When you're sitting there, you're like, almost sounds like a soccer match is going on or something like that. And actually, maybe that is a little bit what it's like for them, because it gives, normally they have to behave in a very subdued way. And this allows them to be very active, to challenge each other, to sometimes make fun of each other, but at the same time to collaboratively figure out what does this thing mean that we're studying. So monastic debate is a practice that's done in Tibetan monasteries, especially those from the Gelug school, ages 14 to 34 roughly, up to what's called the Geshe level, which could be considered equivalent to a PhD. And it's a complement to the memorization of philosophical texts. So you can imagine that's pretty challenging to memorize literally volumes of text. And debating helps them to motivate that, because if you don't know what you're supposed to be debating, then there's no way you can actually debate. So you really have to know your stuff. And it also helps them to increase their understanding of what this is all about, because it's pretty complex stuff that they're trying to memorize and understand. It's practiced for approximately 5 hours a day, again, at least in the Gelug Tibetan monasteries, like Sarah J is a great example of that. Other Tibetan monasteries often do debate, but maybe not as long. And it's an interaction between one or more challengers and defenders. So a challenger would be the one who's also called the questioner. He's standing up, and the defender is sitting down, like you saw in the previous picture. So you see one sitting, this is the defender, and one standing, this is the challenger. So that's always what it looks like, but there can also be more than one challenger or more than one defender. So what happens is, first the challenger determines the topic. I mean, obviously it's going to be about the text they've been studying, but they would be asking sort of questions. Then they would first establish common ground by reciting the relevant sections of the text and enumerating definitions, those kind of things. And then challenger would pose syllogisms. He would say something like blah, 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 and then it follows that something else. And then defender has just a limited set of options. So the defender actually won't say very much. Actually, here you see one Tibetan monk, Kalden, who's coming to Emory in the fall. He's debating me on neuroscience, and I get very quickly lost, obviously. So the defender would say either I accept, so you agree with this, or I don't accept, what is the reason? And then the challenger might give a reason, and after the challenger has given reasons, then I might either respond, well, the thesis has not been proven if I don't agree with that reason, or there is no logical provision. I mean, it's a reasonable reason, but it just doesn't apply to this particular case. So it's a very structured kind of exchange of information. It also makes it quite challenging to learn, because it's quite unnatural to the way we communicate. And they also have particular movements associated with this kind of practice. So when you see this going on, you see them making these kind of clapping movements. It makes it all very lively and very exciting. So they keep going until the defender contradicts himself or herself. Nuns also practice debate nowadays. So it's all about finding contradictions in logic. And then you can hear them say tsa, and they make a different kind of movement. So example interaction, this is taken from a textbook. So they start with saying di, which is invoking Manjushri, so the subject in just the way Manjushri debated. Manjushri is the deity of wisdom. Is whatever a color necessarily red? And then the defender might say, I accept that whatever a color is necessarily red. And then, just to be sure, they repeat, it follows that whatever a color is necessarily red, I accept. And then they say it absurdly follows that the color, so they won't say absurdly, but just to clarify what's going on, the subject, the color of a white religious conch is red. And then the defender says, well, wait a minute, why is it the case that the color of a white religious conch, which is this kind of a thing, is red? Because of it being a color. And, well, so obviously that's, there is the funny reasoning, because why this initial statement is kind of weird, because whatever color is obviously in the real world not necessarily red. So you can see that they go through this kind of a whole logical nitpicking sometimes of statements. Actually, for language theories, it's probably also pretty interesting to see how this whole thing plays out. But anyway, this is roughly what they're doing. So then we were like, okay, well, this is pretty interesting. Let's measure the brains of these monks as they're debating to try to figure out, get some aspects of what's going on. So this is how we started to take neuroscience in the wild. So let's have a look. Let's see whether this video works.
3, 2, 1.
So it starts typically pretty leisurely. Here's again the defender sitting, the challenger is standing. Tapke is actually monitoring what's going on. He's pressing buttons on the EEG system, so we have triggers of particular things that are going on. So this is one way in which we try to make sense of what's happening. I mean, I don't speak Tibetan, and neither do my colleagues, but we work with these monks to find interesting bits of time at which we will look at the brain activity of these monks. So in particular, we decided to focus on when are the monks agreeing and when are they disagreeing, and are there differences in the synchrony between their brains, between the agreement and disagreement. And then I'm sitting next to Tapke to write down whatever he says is the reason that he presses the button. It's our sort of very low-tech way of doing neuroscience in the wild. And obviously we also capture these videos so that later on we can then look for other things in the video as well, or have other monks rate what's going on in the video. So yeah, you can see in the beginning it's still, well, this is a regular exchange, but you can also see that at some point it gets pretty exciting. So. Yeah, so you can see it's a pretty lively exchange of arguments. There's a lot going on, which makes it kind of intimidating to look at it for neuroscientists. But yeah, the way we started to go about this is having monks press buttons. Here you can see other monks in next sessions, videotaping the whole thing, and then trying to look at whether there's anything sensible in the data. So the way the study worked is as follows. We actually look at two aspects of what's going on. First, monastic debate as a sort of state. So what literally are they doing in the moment? Recording the brain, in particular EEG, while the monks are debating. A monk watches and generates triggers like you would do in any EEG study. So they will just say, at this moment, this is going on. Then our very, very simple design, which obviously has many flaws, but just to get started, we just wanted to compare beginners and more experienced monks and see whether there's differences, but as a function of practice. And we also wanted to compare two types of debates. One is called a counting debate, in which they focus more on enumerating the different things, definitions. It's more memorization based. And then logic debate, which is more focused on finding these inconsistencies. So the counting debate is considered to be easier, while the logic debate is considered to be more difficult and more with the meat of the business. And then we can also look at monastic debate as affecting mental traits. So it's a method of training which should affect or change the way people think. So how does monastic debate affect cognition and emotions? And again, comparing beginners and more experienced monks on various measures. So those of you who have done any work on non-undergrad populations will already realize that this is going to be very difficult. So I'll show you some tiny successes and loads of failures, but we'll talk about that. But let's start first with the EEG business. So what we looked at here primarily was we recorded the brains of two monks while they were debating. And in particular, we noticed it's a social interaction. So does it affect interbrain synchrony, the synchrony between the brains of the two monks? And in particular, we hypothesized that when they were in the state of agreeing, settling on the same premises, that their brains would be more synchronized than when they were disagreeing. And I think it's kind of interesting that this is a fairly high-level sense of what could drive interbrain synchrony. It's much more complicated than some of the data that Susanne Dicker showed us yesterday, which is really like, well, if people are watching the same kind of movie or listening to the same explanation of the teacher, then their brains are more similar. In this case, it's a more high-level thing. Surprisingly enough, we did find evidence for higher interbrain synchrony during agreement epochs that were designated by the monks compared to disagreement epochs, and it was primarily in this frontal channel FZ and a little bit in this other channel to the side. We then obviously didn't want to go by just one experiment, so this study consisted of something like 50 or so debates of monks. We then went to replicate that in a more controlled study. So actually the first study was us, going to India a few times, saying, okay, what is this thing? So let's try many variations of debates, different experiences, different lengths, different teacher present, teacher absent, whatever, all the weird things that we could imagine, talking to the monks and say, what do you guys think? Let's try this, let's try that. But obviously not great for a scientific study. So study 2 was like, okay, now we've done some stuff, seems like there's something going on with agreement, disagreement, so now let's try to standardize. And this is actually a big concept for people that are not scientists, and especially monks. Like, guys, we have to standardize. So that means that people cannot walk in and out when monks are debating because they might be distracting the monks. It means that every time you guys debate, we're not going to make sometimes 10 minutes, sometimes 20 minutes. It has to be 15 minutes and then we quit. It means that you guys have to debate about the same topic. And actually, we want you to also rate the debate. So give a score. And that was a whole different disaster. try to make them consistent and make the different monks consistent in their rating of things. So actually this took even more effort, because after we'd done this initial study, I forced the monks to go back and watch the video, so that we wouldn't have just one rater, but we would have 2 more raters looking at the videos, and then look at the consistency of the ratings of agreement and disagreement between the different monks, and have them talk to each other, like, what do you do? What do you do? Can we compare? And there, obviously, I also had to rely on their expertise, because I don't speak Tibetan. So, and they would be much more fluent in actually talking about these things in Tibetan. So it's a long learning process to actually make this happen. But then again, because it was more controlled and we had a lot more data in this second experiment. I mean, we had the same amount of debates, but we had these re-ratings, which made it more controlled. And then we still replicated this agreement-disagreement effect, but we would now see more electrodes that showed the effect, but still also a pretty strong frontal focus. So, and actually, interestingly enough, overall, there was not so much of a difference between beginner and experienced monks, and that, unlike what we hypothesized. So red are the beginners and blue are the experienced monks, and the effects are really not consistent or significant. The only significant difference is really agreement-disagreement. So the other message that I have was, it's really important to listen to each other. So continuously try to tune in, like, what's going on. Is it not that the scientists are having the are overruling the monks, or the monks are overruling the scientists? Are we communicating? So this is why it was really important for us to collaborate with Science for Monks. So the head of Science for Monks, Bryce Johnson, is always joining us, or most of the time joining us on our trips, so that he can monitor, like, are we all talking to each other and are we understanding each other? And he's been helping us with that. And then, one example of how this can be really helpful is that the monks had made this interesting observation that when we debate, initially we might be quite scattered, but then as we continue to debate, we sort of forget everything around us, especially the better debaters. You could be walking by, there could be all kinds of stuff happening, they wouldn't notice, at least that's what they claimed. So I was like, oh, interesting. So there's this EEG signature of absorption in sort of frontal midline theta waves. So would that also increase over the course of the debate? And obviously, wouldn't be standing here if that weren't the case. So if we look at frontal theta Z transformed over time, so 0 is the start of the debate, and 10, 15 minutes is the end. This is study 1, so there's quite a bit of variation in length. So this part of the graph I wouldn't really take seriously, so it looks like it goes down, but it's just a weird averaging artifact of different lengths. It goes away when you time lock to the end of the debate, but that's a different way, a weird way of plotting the data. So anyway, you can see an increase in frontal theta for beginners and experienced monks, but actually if you do the stats, the slope is higher for the experienced monks. And this also replicated in the second study, where also we found that the frontal theta increase was more for the logic debates that are more challenging than for the counting debates, where they might sometimes be just like, well, whatever, kind of boring. Yeah, so it was consistent between their subjective judgments and their objective judgments. Now, to really believe this, I still want to do some experiment which we have been thinking about but not quite implemented, where maybe we'll show them some light flashers or something like that and actually look at to what extent does their brain activity process these light flashes that are happening in the periphery or something like that. But it's pretty challenging to come up with a good way to actually do that, but I think it's some interesting first results. Yeah, that shows up in different channels. So this is just the magnitude of the theta slope. So yellow is higher theta slope than blue. Blue is sort of flat theta slope. And this is beginner monks in the top row and experienced monks in the bottom row. So you can see overall this increase in theta is much more for experienced monks than for beginner monks. And you can actually see it's almost a whole brain kind of thing. Interestingly enough, during logic debates, especially at the temporal theta, not so much frontal midline theta, although when we look at frontal midline theta, we do see these graphs that I just showed you. But apparently it's not just frontal midline. Anyway, so those are our first attempts at trying to figure out what these guys are doing while they're debating. And obviously we have a treasure trove of data there that we're still looking more into. One additional finding actually that I didn't put in this presentation is that whenever they clap their hands, it looks like their interbrain synchrony is also increased after the clapping compared to at other random moments. I'm still trying to replicate that in another study, so that's why it's a bit more speculative. We're also looking at when we observe sort of this kind of anger-like activity, does that affect interbrain synchrony? So there's many things that are occurring, and we are still looking at that. Well, the other approach that we're taking is actually trying to do some experimental measures, cognitive measures, emotional measures. So here you can see monks sitting there in our lab in the monastery. We take them into a classroom, empty classroom, and we give them tablets to do cognitive tasks. In our very first visit, we had them do tasks on computers, on laptops. That was a disaster because especially the older monks, they just found laptops very difficult to handle. Now tablets are a little bit easier to handle for monks, for anyone really. That's how they've been designed, so that works a bit better. Although still the older monks find it a bit more difficult, but it's better. And so we asked them to do tasks on cognitive functions that we think might be trained by debate, such as logic, memory, attention. We also asked them to do questionnaires on paper. And one example of such a task is this sort of logical reasoning. So example question is, you get two premises: all engineers are swimmers, all swimmers are gardeners, and then you're asked to draw a conclusion from this, which would be the correct conclusion would be all engineers are gardeners. So this actually task has 24 questions with different kinds of logic, syllogistic logic, conditional logic, and relational logic. So it's kind of nice to see, are there changes in the monk's ability to reason logically in Western logic. Actually, one monk said during our study, that was kind of interesting, he's like, oh, that's an interesting way of doing logic. Can I get these questions so I can study them at home? But that also shows actually that an immediate problem of these tasks is that they've been really designed with a Western undergraduate in mind. And I'm still thinking about ways that we could maybe rework the task so it works more for the logical structure they've been working with. So you might have remembered from the sample exchange that when they're debating, they're saying take the subject, this and that. It follows that something else. So it's a different order in which you put these phrases. And maybe if we could rephrase the experiment to also be like that, then they would do much better. So if you look in general, you see that they do okay, but they don't do stellar compared to a Western sample. Although we still already try to make it a little bit more Tibetan, so we put Tibetan names rather than Western names, and we replace some objects with objects that are more common in the monastery. But overall we did observe an improvement in accuracy between beginner and experienced monks, but accuracy is not that high. And we also, actually, that was quite interesting. It looks like the monks are relatively good at syllogistic logic and at conditional logic, whereas actually in a Western sample you would find that the relational logic is the best and conditional or syllogistic logic is the worst. So although, I have some doubts about this particular task and this data, it's kind of interesting that it shows, these patterns. So we're still looking into this, and especially also what questions do they find difficult, which ones are they really good at, and it still needs some work, but interesting starting points. And then at the same time, other reasons to worry about these data or to not, to not take it for granted that this is like final data is that monks, especially the more experienced monks who should be better in a lot of cognitive functions, they also have more trouble with tablets because a lot of the experienced monks are monks that might have come from Tibet. So yeah, and you can see that very clearly. These are data from a flanker task, little reaction time task that we do at the beginning. Average response time for beginners is like 680 milliseconds. Average response time for experienced monks is 760 or so milliseconds. Obviously, one difference is also age, but even if we regress out age, we cannot quite reduce all these differences to zero. So there's probably more going on than just age, and it's also a lot of cognitive style. So this really opened my eyes to how Western biased all of our neuroscience and cognitive science is. So it was pretty interesting. Still trying to struggle, like what's the most sensible way to go about this. And one idea we have is try to work with the monks to develop tasks that are based on what they're doing rather than what we're used to in our Western science. Then we also were thinking about emotions, because you can imagine that when you're sitting there, some challengers towering over you, they're teasing each other, they might fake anger or might actually get angry. It involves quite a bit of emotion regulation to be successful at debate. And this is actually also what the monks have been telling us. One of the more consistent things they've told us is that they say, well, you know, when we come in, we're quite angry little boys, and then over the years you become more calm and peaceful. And even in debate, they might look angry. The most striking thing I found, having watched like bazillions of debates, is just how quickly they can flip between anger and joking and all these different emotions. So while they have these emotions, they never stay very long. So can we measure that? Well, we translated a bunch of questionnaires from Western emotion research into Tibetan, which was actually, by the way, another thing that took forever to do, because we had many days of discussions with the monks about how do you translate this word or that word. And then sometimes still nowadays when we revisit these data and look back, it's like, well, do you mean this? Or, well, we translated it as that, and still we're not quite finalized. But these are interesting data that suggest that difficulty in emotion regulation scores decrease with experience in the monastery. Well, this is just some preliminary data, but interesting suggestion. We also have been doing some experience sampling. These are actually data from that I collected last year at ETSI when I taught there at Drepung Monastery. And well, here we just followed a bunch of different emotions over time. Our first, one of the things we also included was tiredness, just as a sanity check, to see whether the monks took it seriously. So we asked them to fill out these questionnaires 5 times a day on their smartphones, most of them. Some did it on paper, but actually most of them actually really liked the smartphones. And we had a WeChat group, and then 5 times a day we put the link in the WeChat group and said, can you fill this out? And a lot of them were quite in it, and you can see that for tiredness, they report feeling more tired in the evening. So that's good. They actually do seem to do something sensible. So what else do we see? I mean, so we recorded, for example, positive affect from a bunch of the words from the PANAS positive negative affect scale. I think most of it, except for a few that I deleted, that didn't seem to make sense. And you can see overall pretty stable positive affect, not too many changes. This is like average across a sample of 70 or so Tibetan monks that were participating in this study. Negative affect in general will be very low, at least according to their self-report. This is all some very experienced monks. Did I do something? Oh, okay, no, that was just my clicker. yesterday we had some disasters with screens going up in the middle of the talk. Anyway, again, this is very preliminary data and still have to sort through that. We're now collecting data from more beginner monks and then comparing beginner and experienced monks, and also looking at how their debate affects these emotions. One interesting thing that we found so far when looking at these questionnaires, here you can see the actual questionnaire with the Tibetan words and then the ratings, is that when we consider positive and negative emotions, actually our classification of positive and negative emotions is mostly based on the hedonic value. So we would say excited is typically positive, fearful is typically negative, proud might be positive, ashamed negative, and so on. If you ask the monks to classify positive and negative emotions, then it's more about the moral value. So excited would not be such a positive thing. It would be more like, something that's, you want to be calm. And actually feeling ashamed would be quite a positive emotion because it's something virtuous. If you're ashamed for something you've done wrong. So by looking at the correlations between the different emotions, sometimes we found a correlation between feeling ashamed and feeling, say, proud, which was kind of weird to us. But then when we talked to the monks, actually this made a lot of sense. So I think that's, again, some very interesting things that are in the data that suggest that, well, the way we process our emotions might not always be the same. So in summary, in this study, we were working on data collection in a very complex situation with not so controlled conditions. Could be people walking in, sometimes even like people from the Tibetan government that are visiting, and then the monks are like, okay, yeah, this is our science center. There's some Western scientists doing experiments. And we're like, no, not now. Dogs, cows, and all of that fun stuff. It questions the generalizability of our normal lab science because, all of these tasks maybe don't quite work in a lot of other populations, but it's very rewarding. And this is a particularly cool moment when Calden, again, he's coming to Emory in the fall, he presented our findings at the International Conference on Meditation Research in Allahabad, India. So that was very, very inspiring. And the research thereby has an impact on the real world, on the lives of these monks. And hopefully also on the lives of people. Maybe in the West, eventually, if our research shows that these practices are helpful and beneficial for people, maybe then people in the West would find it interesting, like maybe we can use some of these practices in our education to make it more active. So, yeah. So then, in the last 10 minutes or so, let me talk a little bit about how we get from monks to dancers. Again, a very convoluted story. I was presenting some of this research to visiting people from the American Air Force that were interested in research outside the box, and especially social neuroscience. And they were fascinated by this research, and then they asked me to submit a proposal, and then I was like, well, maybe we can study the contributions of movement versus the sort of logical thinking to this interbrain synchrony. And how do we study movement? Well, as was mentioned in the introduction, I'm a dancer myself. So I thought, well, why not work with dancers? And these two dancers are actually pretty interesting. They're from a movement collective called Random Collision, which is literally a random collision of lots of dancers, choreographers, and also scientists that have been collaborating with these dancers. And they've been investigating social connection through movement research, so through moving with their body, for many years, and thereby they have a very rich phenomenology of how you can connect socially in many different ways. They've also been collaborating with social scientists to see how that affects the audience that's looking at the performances. So that's how that came about. So the study design, original design in the grant was something very nice, like a 2x2 design. Dancers can increase their social connection or decrease their social connection, and they can increase and decrease their mental connection, and they can separately do that. I discussed that with the leader of Random Collision. That seemed like a great idea. So how does interbrain synchrony change during physical and mental connection? Is interbrain synchrony more driven by the physical or the mental connection? And maybe there's different brain regions, different electrodes that are active in physical and mental connection. So it seems pretty nice. Then you go and rehearse with the dancers in the studio, and then after a while, something different comes out. So just, well, we don't really have that much time, but just to give you an impression of this is what it looks like in the studio. Of course, you have music, because otherwise, without the music, the dancing doesn't quite work. Obviously, making it a bit more messy, but yeah. Here they were exploring some aspects. I think they were disconnected in this particular case. And you can see us also moving around with the cables to try to make sure that they don't trip over the cables and break the system or break themselves. Here they are actually pretty chill. At some points it got pretty exciting. But yeah, this is roughly this situation in studio. So then, after the situation in the studio, we got to a different design. This was developed in collaboration with the dancers, and so we developed a show which was based around 5 different concepts. So they felt one important way of connecting with each other is what they called void. It's sort of based on a Buddhist idea of emptiness, like you connect by actually forgetting yourself, your own sense of self, blurring that boundary. Okay, then we said, okay, well, that's cool. Very difficult to study scientifically, but okay, well, so let's do also something a bit more controlled. So it's like we thought rhythmic movements, like you had finger tapping studies and all of that. Well, that was a bit too simple, so they wanted to do tendu, because that's a compromise, a ballet movement. Like you can actually, like, it's always standardized, it's the same movement. Okay. And then they did something where they had particular rules for, like, based on their birthday and like on what counts they were going to move and stuff like that. Okay, so that was sort of more movement according to rules. And they had one body where they were trying to move as if they were one organism. Dialogue, where one dancer responds to another. And shift of focus, where we are trying to disconnect disrupt the connection by having them focus on another person. So that might be they would go engage with somebody in the audience or with the composer or with one of us who was running around with the cables. So yeah, we got some interesting situations, and then this was the show which we took all around the Netherlands in 5 different places where the dancers did this thing. We recorded their brainwaves, and between every section, we had some dialogue and discussion with the audience about what was going on. The dancers would reflect on it. We had 2 people, like my PhD student Lionel, would respond to it with poems, with poetry, and then from a science perspective. And then we had a dramaturg who would speak in poetry from the artsy perspective. And then this was how we collected data, or at least tried to collect data. So let's see, we have some of this as a video. Actually, this is a video made by the university newspaper, so it's kind of cute. So they also decided that it would be fun to have me dancing in here. It was just me hanging out before the show and doing some ballet, but that was not part of the show. But then what the show was actually...
I always like to say that I'm just doing weird things. And I guess it's kind of true. I'm not into doing the stereotypical, just focused on science, trying to be the most successful person.
Let's see, I was trying to get to a different part of the video because we don't have too much time, but my cursor doesn't want to cooperate, so let's see whether I can... then show you a part of the actual show. Oh, maybe not. Okay. Well. Anyway, it doesn't look like it wants to get to the right piece of the documentary. It will be online next week, so then you can see the whole thing. Actually, this was an interesting bit to show nevertheless, because we're like, okay, the show is, as you can already tell from my story, pretty complicated, so not very easy to deal with from a data analysis perspective. So what we then did was we said, okay, well, that's cool. We need to give freedom to the dancers. So let's then, in addition to the show, let's take these conditions and turn them into a lab experiment, which is a bit more controlled. So the dancers would only be moving their hands instead of the full body and getting tangled in the wires and all of that fun stuff. And so this is one of our dancers doing our lab experiment, and then we'll take that to non-dancers to see, well, if you're, say, moving while touching another person or moving independently, moving in connection with a prop, how does that affect the interbrain synchrony? So we can make more controlled statements. So how do we analyze the data? Well, you could say compare the overall interbrain synchrony in the different conditions that I outlined, like the void and the tendus and these different names. But the challenge here is that the differences overall tend to be pretty small. So this is an example of what the interbrain synchrony in the frontal channel FZ, what that would look like over the course of the whole show. So it would start with the tendus and then these other conditions. And you can see, well, it's very hard to see any patterns. Actually, this is encouraging. We can see in the shift of focus where they start to focus on something else, not on each other. Looks like the interbrain synchrony decreases, but I mean, this is just one show, and yeah, hard to generalize. Anyway, so we have to do something smarter. Maybe we should actually look over time within particular segments at what's going on. So we now are currently rating various dimensions of what's happening, having multiple students sort of look at these shows and saying, okay, what changes in terms of the synchrony, where we mean like how much they're moving in sync, literally. Mimicry, distance as a more objective measure, so we can check like how reliable are those raters, and then expressiveness, and then relate these changes in ratings over time to the interbrain synchrony. So that's analogous to what we did with the monks, where the monks were actually sort of rating what was going on from moment to moment. And with the monk data, I must say that was the most valuable way to look at the data, the moment by moment changes, rather than just, you do something for 5 or 10 or 15 minutes and then take an average across that. That just didn't give sensible results. And then the final way is the one I already mentioned, taking the data as an inspiration for a lab experiment. So tendu would be translated into rhythmic hand movement. One body would be touching the other person while moving, so not moving freely, but always touching. Dialogue would be responding to each other's movement. So one person is moving, then at some random point they stop, and the other person has to take over and respond to that in movement and go back and forth. And then seeing like how does that change the interbrain synchrony. So I don't know yet, this is going on. Here are some pilot data from our dancers doing this kind of experiment. This is from the over 1 minute, how the interbrain synchrony changes when they're moving alone. When they're not facing each other, it's actually relatively low. The different colors are 2 times that we've done the experiment. Facing each other seems to be higher. In general, we have this thing that very often when they start out, this interbrain synchrony is high. Suggests to me a little bit that, initially it's related to attention. So if they're all on it, and then they start to sometimes get distracted or not. So yeah, it's, again, I don't really trust any of these data or just pilot data, but this is how we've been thinking about how to make sense of this. So in summary, shown you first data on monastic debate, changes in interbrain synchrony between agreement and disagreement. Might also be a training of concentration with this prefrontal theta thing that seems pretty consistent. And the examining of trait effects seem to suffer from a lot of cultural translation challenges, but I think that's very inherent to neuroscience in the wild. Working with dancers is its own challenge. Nice thing of working with dancers, in these dancers at least, they are modern improvisational dancers, is they have a very rich phenomenology of movement, which gives ideas for new lab experiments, but working in the performance itself is a big challenge. Actually, I must also say that while we got reasonable data at the beginning of the show, at some point the dancers were so crazy that we just lost signal, and then there's nothing you can do anymore. It's just like, okay, well, forget it. So we just continued to show, obviously, but we didn't actually get reasonable data. So that's another reason why we developed a lab experiment where they were more constrained so we could actually get data. And we also, we then slowly were getting better at figuring out how to organize the electrodes so they would wouldn't fall off. Because actually, one story I told yesterday in the discussion is that one of our dancers really is sweating a lot, and it was not so bad in the studio, but then under the stage lights, it was a disaster. So our first show, I was completely depressed after that, like this is not gonna work. But then in our last show, we cooked up a way that we would make all the electrode wires go through the cap so that they wouldn't fall off so easily anymore, and that helped a lot. So, slowly you learn how to deal with all of these things. Still, there's always a challenge between scientific rigor versus freedom, especially artistic freedom, but also with the monks. Like, you want to force them to be more consistent, but also you have to let them do their thing. So it's a constant negotiation. Also making sure that all voices are heard, but this consensus building is not very efficient. It takes a lot of time. And repeatability is just a very difficult concept. Like, for the dancers, it was very difficult to understand that we needed to repeat things 30, 40, 50, 100 times, and the same for the monks, actually. And sometimes data recording is quite challenging, at least when you're working with dancers who like to just, once they got used to the equipment, they just completely forgotten about it. And you tell them, please don't touch your head, like don't move the electrodes, and they're just touch their head because they get so much into it. So, yeah. So I think there's many lessons learned. I think it's totally worth doing neuroscience out the lab, but it takes a lot of time. Phenomenology methods are very useful, where you're not just relying on where you actually just ask people to rate what's going on in different dimensions. And it's also at the same time a method for science communication. So it's a multifaceted thing that we're doing. And to make sense of this, we have to be very creative with data analysis. And maybe one way to do is also to take the situation in the wild, but then break it down to lab experiments. And that's it for today. Thank you. Any questions?
So I think it's great because a collaboration with you for your study is really important. I taught tap piano in our first research project. So I'm sorry I didn't go better, but he did a strip test.
Oh, nice.
In Tibetan.
Yeah.
And it turns out that there's no word for pink, and so we got similar things.
Yeah.
And the results were terrible.
Yeah.
Because it's really not something they do. The other thing I noticed is that they also have problems with multiple choice tests.
Yeah.
And the numbers, because I noticed the numbers in your scale were not in Tibetan.
Right.
So especially the older monks have trouble with Arabic.
Right. Yeah. Interesting. Yeah. I should check that. Yeah.
Yeah. So those are some things that I know definitely don't translate very well.
Yeah, although what I heard from the monks is that they claimed that the numbers were not such a big deal. So, but anyway,
for the younger ones probably, but for the older ones, we had clickers and they had to put them back in order with the numbers, 1 through 50, and that was very challenging.
Good point. Thank you.
Yes.
Yeah.
particularly, I think, because what we think, if you change the instrument, is it measuring the same thing?
Yeah.
What is that thing? And actually, a lot of our ideas about what we're trying to measure have been shaped by the tests that we use to measure it. I mean, so is there actually a thing that can be translated, and we just have to figure out how to do it, or?
Yeah, I was envisioning writing at some point a paper like about these behavioral results that would be something like, well, we take this like association memory test actually that we've been doing with the monks, where we found pretty solidly that the experienced monks would do worse than the beginner monks. That would be our association memory, where the monks also said, well, you know, why I don't care about these random words, why should they be associated? And if you ask monks, like maybe a memory test that would be more reasonable for them is actually have them just literally recall a text. And so like you give them some text and they verbatim do recall, and then you measure that, and then you would write a paper in which you would maybe have Western college students do the Western test and the Tibetan-inspired test, and the other way around, and then just report on those similarities and differences. But I'm open to any other suggestions, but that was my thinking so far.
And I think even like with different populations that we study, sorry, maybe this is for discussion. But because we bring in older adults and they're like, I don't want a robot like this, or, you know.
Yeah.
And we're lucky with the dance that Madeline Hackney was a professional dancer before she got the PhD, but that with the TAB kit, and then like embed them in the scientific training, and then say, like with the meditation, it's a classic example of Westerners going, oh, just meditate and we'll measure your brain, and it turns out there's all these styles of meditation.
Yeah. Yeah.
Same with dance. We would not have progressed if she hadn't been a dancer, because we had like really bad ideas about
Yeah. Yeah, so it's also a matter of just doing a lot of discussion, and then for the monks to figure out what it is that we're doing, how this whole thing works, like with these tasks, and getting examples, and then eventually I think they'll be able to also generalize, and meanwhile we're learning more about debate. So I actually got some debate lessons from Western monks that are studying in the same monastery in English, because for the monks to teach us in English was a bit difficult, but the Western monks found it helpful, found it quite good, quite okay. And so then as I'm trying it myself, I'm getting this first-person experience of maybe what they're doing, then I think from the collision between the two, slowly you get closer to what makes sense. Yeah.
I probably missed this, but what exactly, how are you defining synchrony? Right, like what's your measure?
Oh yeah. So I glossed over that detail. It's literally phase locking value, which means just is there a constant phase difference over time? Just a very simplest measure. And I haven't tried the other ones, like the ones that Susanna mentioned yesterday, so I cannot comment on whether this is the best or the worst one, but I just wanted to go with a simple one for now. Yeah.
And this was like in alpha, I think, like lower frequency.
It was in the alpha band. Because and again, that was just inspired by the literature, where it's a pretty convoluted literature, but the most consistent one that I could find was frontal alpha. So I was like, okay, let's go with that. And that's also with the dancers, the thing I've focused on so far. Where again, there's an infinite amount of stuff you can do, and I'm also working with some computer scientists to do a major like big data approach on these data. Yeah.
Yes. I was interested in the comment when the dancers said that they felt most connected when they felt a type of void. And because I was wondering, because you push it away, like saying that's hard to measure scientifically, but I'm just wondering if you have more thoughts about that. I'm also like, I don't know too much about meditation, but one of the things is that it's trying to transcend the ego. So there's also something like pushing away the boundaries of the self.
Right.
And I'm interested because my own work is about it. Like thinking more from a philosophical feminist perspective of like the loss of the self. So I was just wondering what's out there and what your thoughts are.
Thank you. I think a very interesting question. So this void, indeed, in this talk I sort of pushed it away, but I do agree it's a very interesting condition. I'm As also mentioned, I'm also a Tibetan Buddhist practitioner, so from that perspective, it does make sense that for the dancer, they feel more connected when they don't have these boundaries of like, I want this and I that. Like they report going more with the flow and not really trying to have any agenda. They're just open to whatever is happening. But yeah, from a cognitive perspective, I don't really know how to have any theories about that. And actually, so far from what we've seen in the interbrain synchrony, it also didn't look like there was a lot of high synchrony. Maybe actually it is because they went to this very non-agenda kind of brain state, and if this interbrain synchrony is to some extent sensitive to sort of effort and attention, maybe it's not measuring this subjective level of connection. So actually what we literally say in the show, we repeat the hypothesis a few times, and it's some, like in a poetic sense, we say something like, what makes connection, what increases and what makes it go away. And then we say, well, sometimes there might, these interbrain synchrony might be reflecting human connection, but maybe sometimes there is actually no connection, and we're there to explore this in our show, and maybe sometimes what the dancers feel and what we see in the brain is diametrically opposite. So I think that's it actually is a very important point for science communication as well, because when people see this kind of a thing happening, they feel like we're going to tell them how it works, right? And we have our oracle, that's these brain waves, where literally we show them, at some point in the show we also show them the raw brain waves coming in. But obviously there's nothing much you can make of that. Anyone who's done EEG will know that. But for people, they still feel like this is going to give us the answers, and we literally have to tell them, like, you know, we have to do a lot of data crunching, and it will take months to analyze and years to publish these results. So I think making that point is actually a very important part of the performance as well. Yeah.
Do you think it might also be a case of a Western bias, where we in the West are still holding on to individual and autonomy?
Yeah.
Like it seems like something that we value very highly, while maybe we're asking not the right questions. Like maybe when brains are synchronizing, it is something else, not an autonomous self, but something else that's created.
Could entirely be the case. So I think it's still quite open what this interbrain synchrony is, and it could also well be, that's my current sort of working hypothesis, that maybe frontal alpha synchrony or interbrain synchrony in frontal alpha might be something different than, say, posterior alpha or theta, or I don't know. I don't think interbrain synchrony typically works well in the higher frequencies like beta and gamma, because it's just too fast for brains to synchronize. We're still completely exploring all of these things. And I think that's actually where the dancers can be really helpful, because they have this very rich phenomenology on the ways in which they explore human connection, much sort of richer than I could have envisioned. I mean, it's often very annoying, because you're like, okay, so you're going to do this, and then they take you by surprise and do something completely different. You're like, okay, but then, you know, eventually maybe you'll get to much richer ideas about what you could manipulate. So we never had envisioned this void condition at all, for example.
Shall we maybe break for lunch?
Yes.